Hello! When I talked about this concept of a string anchor that I was working on that my friend Dale was going to machine for me in his very well-equipped garage machine shop up in New Jersey, I guess I kind of envisioned that there would be like another video talking about how that had turned out, and then there'd be more along the development process before we saw anything like an instrument. But I kind of hopped ahead and made, just as soon as the string anchor arrived, I made this instrument, which is a very rough prototype, but it actually plays. It stays in tune, plays, and is totally delightful and fun. So we're going to talk about the string anchor, but actually already in context of that instrument, whose strings it is anchoring. Okay, so of course the problem with talking about these string anchors is that they are eensy-weensy, which they have to be, right? We're holding these eensy-weensy strings and we don't want it to be too heavy or we'll get neck dive with an overly heavy headstock. But I've printed out a picture nice and big so you can sort of see what's going on inside there. The blue thing we're looking at here is a string. It's passing through this hole, which you can see is generously chamfered here on the top. That's the side that's facing the underside of the headstock. And it comes out much smaller on the bottom. The goal is that's going to be pretty much flush, although I have yet to test, you can see, cutting the strings. So anyway, that's that hole. It's a through hole from the flat to the flat, and the blue thing is the string. And one of the design challenges is that we have to make this thing work equally well, and by work well, I mean don't let the string move once it's tightened. We have to make it work equally well for this diameter string, which is drawn here in SolidWorks at 0.009 inches. That's like, I don't know, it's around 1/4 of a millimeter, I believe. All the way up to, in my design specs, I said make it work up to 1/16 of an inch, which is more than I'm currently working on, but yeah, that goes quite a range from 9 thousandths up to 63 thousandths of an inch. That's 1.5 millimeters there, 1.5 millimeters. So to have something with such a huge percent difference in size still be able to be clamped requires special consideration. But I've drawn it here with the 9 thousandths diameter string because that's probably the most challenging condition. Because it is, yeah, it's just hard to hold narrow wires. And the tools we're going to use to hold it, in addition to this beautiful piece of steel that Dale machined up in New Jersey, this one and the ones like it, although not all exactly like. There's a big black X on this one, which I think Dale said is because it's really, really super extra great, like better than the others. I think that's what he said. Anyway, the way it's going to work is first have this thing in there. That is a BB. It's a 0.177 inch BB, which I think is 4.7 millimeters. I forget right now. And it's going to be followed in there by a set screw. You see this has sort of an inverted point, like a cup with a kind of a sharp ring there on the edge of it. That cups the BB quite nicely, as you can see in the model here. And yeah, make sure that it's pushing straight in. And if I turn this all the way in, it's going to make it so a string will not go in. You can kind of see the glint of it there in the hole. Do you see the glint appearing and disappearing? That's when you know, okay, it's all the way in. Oh, it's not all the way in. And at that point, you could insert a string. And once the string's in and through, which I guess I could try here with this little bundle here. Once the string is in and through, like this, you can see it coming through. Tighten this is a 3 millimeter hex wrench. Tighten that, and did you see that little bend? Watch, bend as the BB presses the string down into that conical recess formed by the initial drilling operation on that side face. So that string is well locked. It did not take much torque to get it like that. And yeah, I'm delighted with how that mechanism works. All right, so that's what's inside there. And that's how it works, and that's how the strings are being anchored. And as you can see in this case, it is working. This one's 20 thousandths of an inch. This is 28 thousandths of an inch, 38 thousandths of an inch, 48 thousandths of an inch, and it seems to be working equally well for all of them. So I feel like that's a big success. Now, bear with me. We're about to do something that's very frightening to me. Hold my hand, stand by me. We're going to cut the wires. Now, cutting guitar strings, in this case electric ukulele strings, I don't know, it's always an anxiety-inducing process for me. There's a finality to it, and boy, oh boy, this is something I need to get used to because I've done it a lot before and it's always turned out okay. I'll need to do it a lot more in the future, given my current plans. But yeah, that finality is it's just triggering or something. So here we go. These are hard wire cutters. Hopefully they can do this flush cut without being dented. All right. Oh, that's good. I can rub my finger over that and it's flush enough that it's not catching. That's great. I don't know that I'd put that up against my cheek, but it's pretty good. It's pretty good. Yeah, that's better. So you have to really work to get this flat backside flush against there. But I do think I'm seeing some damage. I think I'm seeing some deformation of these jaws. Maybe not. Maybe it's just metal plating residue. Okay. Yeah, so that's pretty good. We've done it, and look at that. I'm dealing with my anxiety constructively. Well, I'd say all in all, that's a pretty good success. A string anchor that anchors the strings.